Dear students, today we shall discuss about the stepper motor interface with your microcontroller with 8051. So first let us try to understand what is this stepper motor. We have already seen the continuous motion motors wherein when you have the continuous magnetic field and when you pass the current, there will be a continuous motion, rotation like this. But in the stepper motor, right, you will be having the intermittent magnetic field generated. There are different principles based on which the different types of stepper motors work, but generally, so in order to make the rotation in the stepwise manner, we are going to generate intermittent magnetic field or the intermittent current pulses will be provided. So now as long as the current is continuous or the magnetic field is continuous, you will get the continuous rotation. But instead of this, if you provide the current in the form of intermittent pulses like this, the rotation of this motor is also going to be intermittent. So these stepper motors basically rotate with certain step angle and the motion will not be continuous. Now suppose if this is the rotor of the stepper motor, let us say that initially it is at this position. Now depending upon the requirement, it may go to the next position here. This is going to be the step angle, then it is going to the next position, it goes to the next position, so on and so forth. Instead of going from here to here continuously, it will jump in one particular step. So that is the reason why it is called as the stepper motor. You find them in the wristwatches, computer peripherals, so many applications we are using the stepper motor. So now in this particular experiment, we will try to see how exactly a stepper motor is interfaced with your microcontroller. As usual, I have got the computer as I have already explained you earlier. Then you have got your serial cable, then your microcontroller 8051 here. Then from the microcontroller, the designated ports are used to the stepper motor interface circuit. This is called as the stepper motor interface circuit. So from here, the stepper motor is going to be connected. So this is the actual motor which is going to be controlled either in the clockwise direction or in the anti-clockwise direction. The speed of this stepper motor can be adjusted by controlling the delay between the successive steps. The number of steps will always remain fixed. If the step angle is 1.8 degree, so for 360 degrees, it will take 200 rotations as we know, right? So if it is 3.6 degree, it will take 100 rotations. So those number of rotations will remain fixed. But between the successive steps, how you would change the delay, that will decide whether you are able to make it rotate faster or slower. That means you are controlling the step rotation. Okay. So now the speed is controlled in that particular manner, and that particular instruction is given in your program that you have written in the computer, which you are again burning in your microcontroller through the designated ports, the different codes corresponding to the input that you are going to give to your stepper motor, which are the digital inputs, right? So they are going to make the control to have over the stepper motor, which we will demonstrate with the help of this particular presentation. Now, if you look at this particular program, all these parameters we have already seen earlier also. So, but only thing is that we will look at this particular program from the point of view of the stepper motor control. So you have the header file included here, as you know, right? So then you have got the delay programs here, and you have the infinite loop with the help of wide one. Please see here, I am using port 2 here. I am using port 2 as the designated port to control the stepper motor. So the same port I have used. These are the digital codes that I am going to give it to the stepper motor in order to have their rotation in the counterclockwise direction. So these digital codes are derived with a particular method which I will give you in the form of the manual or something like that. So these are the digital codes 0E, 0D, 0B and 07. See, these are the digital codes which are ported to the interfacing circuit of your stepper motor by means of port 2, and after each code is ported out, a suitable delay is introduced here. You can see here, this is the first code followed by a certain delay. This is the second code followed by the certain delay. This is the third code followed by certain delay, and this is the fourth code followed by certain delay. And afterwards, this is a 4-phase stepper motor. So this is going to be repeated. So in this way, the delay program is written here. This is also very simple. int I for I is equals to 0 to up to a certain value. So they have arbitrarily taken it as 30,500 increment I plus plus. So now if you change this particular value, the delay between the successive steps also can be changed. This is the simple program. So if you have any doubt in this particular program, you can always get back to us. Now I will tell you how you will be able to control the stepper motor. Please see here, this is the power supply. This is the power supply and this is the stepper motor, as you can see. So this is what is the rotor or the shaft which is connected, and since you will not be able to see the motion, I have made a small arrangement here. I have put a extended paper here so that you should be able to understand the rotation of this stepper motor. This is one of the stepper motors. It varies from type to type, size to size and all. Now this you are already aware, this is the microcontroller, as you can see. So this microcontroller is connected to your computer through RS-232C cable. This we have already seen. So from the microcontroller, the stepper motor interface, similar to what you have seen as the DAC interface, is connected by means of this FRC cable. Then you will have to provide the power supply here. So 5 volts and ground for the stepper motor as per the requirement of the stepper motor. 5 volt and ground I have already connected, you can see here. Then from this stepper motor interface, as we have already seen here, you can see here, from the stepper motor interface I have to connect it to the motor. That I have done with the help of this particular wire. You can see the connection. This is the simple connection. This is the simple connection what you can see as long as a stepper motor is concerned, right? So now we will try to see how exactly we will be able to control the stepper motor by writing the program. This program has already been written and its hex file is created. Now as usual, I will have to go to flip. As you can see here, this is the flip software. So setting, then communication, RS-232 with the default setting. I will connect it. So you can see here the start application. Once the start application comes, you know that you will have to get the hex file. So this is signed by default earlier one. Now what I will do is I will go to this folder where I have stored my stepper motor program, and anti-clockwise.hex. This is the hex file which is created, that will be opened now. So now once it is opened, as you know, I will have to run it. So it will take a couple of seconds here before it gets erased, then blank check is done, then the programming is done, then the verification is done. So now you can see here this program hex file anti-clock.hex is already loaded. So now if you look here, the motor does not rotate. Now once I click on start application, you can see the motor starts rotating, and it is already simulated here in the form of LED displays. You can see the rotation of the motor. You can see the rotation of the motor here in the anti-clockwise direction. The codes are written in such a way that the motor rotates in the anti-clockwise direction. So now between, if at all you want to control the speed of this motor, what I should do here is I have to only change the delay in the program. So according to the change in the delay, I should be able to demonstrate whether it can run faster or slower. I will reset it now. You can see here, I will reset. Now the program stops. Okay. Then again, I will go here to this particular program. Now you can see here, what I have made is instead of 30500, I have used a delay of 20500, count of 20500. I have introduced lesser count now. So obviously your stepper motor should run faster now, right? So I have created the hex file now again as I did earlier. So now I am going to flip settings, communication, RS232, so connect. So now I have connected the same file. Now I will be burning into your microcontroller after making the change in the delay. So now I will run it. Once I run it, erasing, then blank check, then programming, then verification. So when all these things are done, now you can see here my stepper motor should run now faster. So you can see here the stepper motor now runs faster because I have created the delay lesser between the successive steps. This is how you should be able to run the stepper motor with the different speeds, and you will be also able to run the stepper motor in the anti-clock. I mean, now it is rotating in the anti-clockwise direction. You can make the stepper motor to run in the clockwise direction. Only thing is that the sequence of the codes which we have put there, that has to be reversed. By reversing the sequence of the code, we can make the stepper motor to run in the clockwise direction. You can see here, now I am coming here. So now this 0E should come here and 07 should go there. This is 0E. This should be 07. Now these two you interchange. This is B and this is going to be D. I have simply interchanged the codes here, right? So these codes which are going to your microcontroller. So now again I will save this program. I will create the hex file. Now again I will go back to my flip here, setting, communication, RS232, connect. I have connected it. The same file with the change in the codes is now going to be uploaded, and it is now being burnt into your microcontroller. Erase the previous program, blank check, programming, then verifying. Now if you go here, you can see it should run in the clockwise direction. You can see here now it starts rotating in the clockwise direction. You can change the direction also, you can change the delay also, thereby you can control the speed of the stepper motor. So this is the simple presentation on the stepper motor. Please try to understand these things, because this cannot be done in the simulator as we did in the logic analyzer for our previous programs. Please try to understand, and if you have any doubt, you can always get back to me. Thank you.